Welcome to iLecture-Online, and before we continue with the basic shapes of molecules in chemistry, we're going to talk about something called the VSEPR notation. What does VSEPR stand for? Well, the V stands for valence and S stands for shell. So we're dealing with the valence shell here. And of course, what's in the valence shell? We have electrons. And of course, we have pairs of electrons typically there. And they, repulsion. That's not what I wanted to write. This should be an O. That should say repulsion. There we go. That's much better. So it's called the valence shell electron pair repulsion. And that's really the key to figuring out what the structure of atoms look or molecules look like. And so here the key is the valence electrons that repel one another. So it's the electrons in the valence shells that make the bonds and that also are free to make other bonds in case they bond with other molecules or other atoms. And so we're talking about the repulsive forces between the electrons in the bonds and the free electrons in pairs around the atoms. Of course, we're dealing with the valence electrons. Now, the notation has three characters. It has the first, the second, and third character. The first character represents the central atom, and so we represent that with an A. The second character is an X that represents the terminal atoms, the atoms on the outside of the molecule. And then finally, E represents the free electron pairs. Now, if there's more than one, you will have a subscript. For example, in water, H2O, if we draw the molecule, notice we have a central atom, so that's represented by the A. We have two terminal atoms, so we have X sub 2, indicating there's two of those. And notice that the central atom has two free electron pairs, so we write E sub 2. And so this is notation that tells us what the shape of that really should look like. And later on we'll understand that that shape is actually not just a bend shape where this looks like it's in a planar shape. The orientation of these electron pairs will actually not be in the same plane as the plane of the oxygen and the hydrogens, and you'll see that technically, when we take into account the direction of the orbital lobes of these free electrons, you'll see that's actually kind of a different shape as well, and we'll get into that in just a moment. But just again, understand, so we have to figure out how many atoms we have on the terminal side of all the bonds, how many free electron pairs they have, they repel each other, and they repel each other so that the structure of the molecules will be such that the separation of these free electron pairs and the bond electrons are far away from each other as possible. So that's why you'll see that these will actually bend kind of like rabbit ears out, and they'll then take on a different shape to be as far away from each other as possible, and that's always what determines the general shapes of these molecules. So then come and take a look at the next several videos so you can see all the various basic shapes and how they're created by these repulsive forces.